Okay. An electron is released from a metal surface with that speed. When that light is shone on it, what is the work function? So, question 1. We have to use the formula, what is it? K, oh goodness sake, I'll have to write it down. HF equals KE plus work function. Isn't that right? Yeah. Which is HC over lambda equals a half mv squared plus work function. So work function is HC over lambda minus a half mv squared. H is a constant, C is a constant, lambda is 600 nano. M is a constant, it's the mass of the electron, and V is 154471 squared. So when you guys are ready, you can give me this. Yeah, 3 times 10 to the 8. Oh, Siva, your carbon 14 is decaying. Yeah? You up on Twitter last night again? Until what time? No, let me guess. Not as much as last time. I'd say 3 a.m. Wow, okay. That's late. You went to sleep at 6? And you woke up at 7? 8? Why do you punish yourself like this? You know? Got an answer, Matt? Oh, thank you, Chow. So, this is 3.2 times 10 to the minus 19 joules, which I'll write as electron volts now. 1.998 electron volts. So in other words, 2 electron volts. Okay, 2A. This time, I give you the work function, and I give you the wavelength, and I want the kinetic energy. So it's K, HF equals KE, look, I don't have to rewrite it. I'll just, here it is right here, okay? Or rather, here it is right here. So I want the KE this time. So the KE is HF minus work function, which is HC over lambda minus work function, which for this one is HC over 300 times 10 to the minus 9 minus 3.68 E.
What is the value of C?
3 times 10 to the 8. Oh, for goodness sake, sorry. -9 there. Did I do that mistake in the last one? No. Okay. Pretty small. Thank you. And then I shall put this into electron volts as well. 0.4528 electron volts. Okay. B. What is the threshold frequency? So remember, the threshold frequency is the frequency that gives 0 kinetic energy. So if you look at this formula, if you have 0 kinetic energy, then what's the frequency? It would be work function over h. Yeah, so what did we say the work function was? 3.68 E over, what number is H, Chow? 06, thank you. So this is 8.898 times 10 to the 14 hertz. It's the minimum frequency possible. C. What is the wavelength of a photon with this frequency? Um, 337 nanometers. D. What type of light is this? So if you remember, 700 nanometers is red, 650 orange, 600 yellow, 550 green, 500 blue, 450 indigo, 400 violet. So 350, what do we have when we're at 350? What's after violet? Ultraviolet. So I think we'll have ultraviolet. Okay. How are we doing? I think we'll do number 3. But I won't do the next worksheet because it's quite long and I need to give you some time to get ready to go to the sports thing. Do you have to go? Depends what you mean by have to. You know, you don't have to do anything in life, you know? Like, nobody forces you to do anything, you know? I'm going, if that answers your question.
Where should we go? Sports centre?
Of course you can watch, you don't have to participate. You just want to go to watch and laugh at the other students, that's fine.
I'm not really sure where it is and how to get.
Oh, well, the students are walking down. So I think they're meeting at the front gate at like 2:40 about. 2:40. So you don't have to participate. Nobody's going to, The teachers aren't going to chase after you and make you participate. If you want to just watch people play football, that's fine. You know, they're having a cake competition as well, aren't they? Oh yeah, did anybody in this group make a cake? You did not?
We planned it, but we figured out things.
You planned to make a cake?
Yeah.
And what happened to that plan?
Forgot this today.
Yeah, she forgot it was today.
Well, you could at least go and watch. Yeah. Minimum, you know. Goodness. What was the cake going to be? Just maybe it's a good thing you didn't make it. Okay. Let's see. So no football team in this group? No. No cake, no football team? No. Okay. 3. A 10 by 10 centimeters photocell is made of copper with a work function of 5 electron volts. Light of 650 and intensity 120 is incidented onto the photocell. What the heck's my question? A. How much energy per second does the plate receive? Okay, so look. Here's the plate. It's made of copper. You have your light that comes down. And the energy of the light is 120 watts. No, that's wrong. That should say m to the minus 2. Watts per meter squared. And this is 10 centimeters by 10 centimeters. And my question is, how much energy falls on this? So 120 watts per meter squared, that means 120 joules per second per meter squared. Now, how much do I have here? I have 0.1 squared meter squared. Yeah? So I have 0.01 meter squared. Okay? So I have 1% of a meter squared. So that means I should get 1% of this energy. So I think it will be 1.2 watts per my small rectangle, per small square. 1.2 watts, I reckon. Right. B. How many photons are in this energy? How many photons do we need? So you know, for one photon, what's the energy for one photon? That's HF, which is also hc over lambda. Okay? But if we have many photons, well, then all we have to do is multiply by how many we have. And we know that this is supposed to equal 1.2. So by simply rearranging, I can get n is 1.2 lambda over hc. And the lambda, we said, is 650 nano. Here you go, Chow. You know how to type that in. Thank you. That's how many hit, okay?
What's the unit?
Oh, it's just like number of photons. C. How many electrons are freed per second? So in 1 second, 3.92 times 10 to the 18 photons hit the metal plate. So then how many electrons are freed? I think. We think it should be the same. However, I was trying to trick you here because we don't know for certain that when the photon hits the electron will be freed. Because maybe the photon doesn't have enough energy. So we first have to check, is the HF bigger than or equal to the work function? So let's check. What's H? Well, we know H. That's C. Lambda, we said, is 650. And the work function, we said, is 5 electron volts. So let's just see. Matt, maybe you could just do the left-hand side, and I'll do the right-hand side. For the left, 3.056. Yep. Is that true or false? Is it true? It's false. So I was trying to trick you. The answer here is none. None are freed. D, therefore, what's the current? The current is 0 amps because there's nothing freed. So I was trying to trick you. Okay. And finally, E, the copper is replaced by adamantium. Maybe you've heard of this material. You've heard of it, right? It comes up in your readings. Yeah. Your TV viewing. Adamantium with a low work function of 1 electron volt. Now, I don't know if the work function of adamantium really is 1 electron volt, considering that it doesn't really exist. But I'm saying that's 1 electron volt. Yeah, you know where adamantium comes from? It comes from Wolverine.
Yeah.
Yeah, who else has adamantium?
There's a lot more in the comic book, not really in the movies.
Yeah, okay. Is Captain America's shield made of adamantium?
No, that's
No.
my opinion.
Yeah. It's the same material that Black Panther's suit is made of? Yeah. I don't know the work function of that material either. Okay, E. So if we replace it with adamantium, then what will happen is this 5 instead is a 1. So I think what you'll have now is an equation which is obviously true. Yeah. Is this true now? This is true. So are the electrons released? Yes. How many are released? This many, because that's how many photons hit the plate. So F, what's the current? So remember, Q equals IT. So I equals Q over T. T is 1 second, and Q is the number of electrons, which will be 3.92 times 10 to the 18 E.
Do we have F?
We don't need. The F is the same. No, you have lambda.
Where do you get 3.2?
That's the number of photons that strike the plate per second. So we think that would be the number of freed electrons. So what we've shown is if you have 10 centimeters by 10 centimeters of a material like adamantium, and when your light strikes this, it will release electrons and it will cause a current to flow of 0.628 amps. Now obviously adamantium's not a real material, but I don't know what your calculator uses as the material.
It's not real.
No, adamantium's not real. It doesn't matter. I just needed to make up a metal. So, because I don't know what metal they use in the calculator photocells. You know, this metal here. Because this little metal here will produce a current. Now you can see it's quite small. It's only like 1 centimeter by 4 centimeters. And in my example, I had 10 by 10. Okay. So I don't think you can make a lot of current, because even with a big panel and a made-up material, I got half an amp. So I think that this here would only make, I don't know, I'd say it'd be only like 0.1 amps for this little rectangle here. At most, maybe even a little less than this. Does it say anywhere on it actually? It just says the voltage. Doesn't say the current. Could you Google, maybe just Google like Google what is the current in a calculator? Maybe we can get a number. Or you could Google maybe index something like how many amps in a calculator. Are we getting any numbers?
The solar panel
Yeah.
from the
Yeah.
generated
Yeah.
300 watt hours
Yeah.
of electricity,
Yeah.
which equals to 1.25 amps.
1 point what?
25 amps.
Really? That much? Are you sure?
How much power does a 300 watt solar panel produce per week?
Oh no, that's a 300 watt solar panel is what goes on your roof, not a calculator. Wait, hang on. Wait, stop. Did they say how big that panel was? We can work it out. They say the size of it.
It's about 5.4 feet by 3.25
Feet! 5.4 feet!
or
Thank
95 inches tall.
No, give it to me again. What's it feet? 5.4?
Feet by 3.25 feet.
Okay, Siba, can you type in 5.4 feet into meters? No, into centimeters. And Anda, could you type in 3.25 feet into centimeters into Google? What you get?
5 feet. Yeah, 164.6 centimeters.
164.6 centimeters by.
Or 82 centimeters?
Yeah.
99.06 cm.
Okay. So that means 16306 centimeters squared would give you said 1.25 amps is what you said. Okay, so how big do we think this panel is? How many centimeters squared? 4 centimeters squared? Yeah, so let's calculate. Okay, so. Yeah, it's even smaller than I thought. So 4 centimeters squared.
It's about 3 point.
It's okay, we're not being super accurate here. Yeah, okay, so it's much less than 0.1 amps. You know, it's only it's 0.3 milliamps. So quite small, but that's enough, I guess, to power the calculator. So it works. Okay, let's see. Yeah, the next worksheet, the final worksheet, we'll do next week, and we'll then look at exam papers. I believe I might have more exam papers I got from NCUK last week that I can put on Moodle, more recent exam papers. So they will be good to practice. What did we say? What day are we doing our coursework? Tuesday?
Yeah.
Tuesday, okay. Oh, thank you.